And welcome students to our final lesson here in Programming 2. As we discuss more about interclasses, we have kind of a triple one to talk about real quick. So we're going to do interclasses in regards to nesting, inheritance, and anonymous classes. So starting first with nesting of interclasses, it is legal to nest interclasses within interclasses. Some of you may have already done this on accident. Put interclass inside of an interclass. It's perfectly fine. There's nothing wrong with being able to do that. Now, the rules are the same as what we've already discussed, except the names can get longer. So, for example, if A has a public interclass B and B has a public interclass C, then the following is valid code. A object equals new A, B, or A.B, B object equals A object dot new B, and A.B dot C, C object equals B object dot new C. And technically, you can have, even within that interclass, you could have another interclass, and you would just have to appropriately extend those classes from there. Now, when we look at interclasses in regards to inheritance, suppose interclass has outer class has an interclass called interclass. If you derive derived class from outer class, then derived class automatically has interclass as an interclass, just as if it were defined within the derived class. So the nice thing about this is if you have an inner class in your, let's call it the outer class or the main class, when you make that derived class, you don't have to rewrite the inner class because it's a derivation of it, because it's a derived class, it's automatically kind of inheriting that inner class. And just like with any other kind of class in Java, you can make an inner class a derived class of some other class. So all perfectly possible and able to do. You can also make an outer class a derived class of a different or the same base class. So it's very easy to go through and apply a lot of our rules of inheritance in regards to base class and derived class and apply them here for inner and outer classes. Now, it is not possible to override the definition of an inner class, though, when you define a derived class of the outer class. So in that derived class, let's say here from outer class, derived class, you can't define a new version of the inner class. You can make another class inside of derived class, but it won't overwrite the previous one. Now, it is possible to use an inner class as a base class to derived classes, but we're not going to really talk about that in this lesson because there's some subtleties involved in it that you'd have to manage. All right. Last one that we're going to discuss, of course, is anonymous classes. This is like more of the new thing for this lesson. If you wish to create an object, but you have no need to name the object's class, then you can embed the class definition inside the expression with the new operator. These sorts of class definitions are called anonymous classes because they have no class name. If you recall back in programming 1, we had something called anonymous methods, which function the same way, except now we're taking that same idea and applying it to a class. Right? It may not always be something you have to use, but it's just one more tool in your toolkit. Now, an expression with an anonymous class definition is, like everything else in Java, inside of some class definition. Therefore, an anonymous class has to be an inner class, all right, because it has to be inside of a class definition. You can't just make an anonymous class just floating out by itself and then try to run it. No, you have to put it inside of another class definition. Now, before we go into the details of anonymous classes, let's just say a little bit about how one might use them. The most straightforward way is to create an object of the following. Your class, an object, is equal to new your class. If your class is replaced by an expression that defines the class but does not give any class name, then there is no name your class to use to declare the variable an object. So it does not make sense to use an anonymous class in this situation. All right? So you can't apply anonymous objects to everything. However, it can make sense in the following scenario. Some other type, an object, equals new your class. Because if you look at this, if we look back at the original one, this first type here, your class, is a new your class. So these two are, in essence, a your class object. But when I look at the second example here, the difference between the one and this one is you'll notice that even though it says new your class, some other type is not a your class. And in this example, some other type must be a type such that an object of the class, your class, is also an object of some other type. In this case, you'll replace new your class with an expression including an anonymous class instead of obviously your class. And the type, some other type, is usually a Java interface. It's typically what you will see used here. So interfaces, this is how you might see them used as a class. So let's look at an example now. Suppose we have the following interface: public interface, number carrier, public void set number, int value, public int get number. And we use the following to create an object using an anonymous class definition. Number carrier on an object equals new number carrier, private int number, private void set number int value, number equals value, private int get number, return number. The part in the braces is the same as the part inside the main braces of a class definition. The closing brace, you'll notice though, is followed by a semicolon, unlike a class definition. So that's one big thing automatically we're looking at and say, wait a minute, what's the semicolon in here? Well, the reason is because the entire expression, the whole anonymous class, is, even though we have curly brackets and everything like that, is being treated as a single Java statement. And remember, statements, we end with a semicolon. So the reason why there's a semicolon there for an anonymous class is because Java treats it as a statement, and it's actually not like a full inner class, right? Because you haven't constructed it in such a way that it's not anonymous. Now, the beginning part repeated as follows may seem a little bit strange. New number carrier. The new is sensible enough. We've seen new enough times and used it enough times that we kind of know what the purpose of new is. But then what is the point of number carrier? It looks like this is an invocation of a constructor for a number carrier. But number carrier, if you remember, is not a class, it's an interface. Therefore, it doesn't have constructors. Well, the meaning of new number carrier is simply implements number carrier. So when Java sees this with an anonymous class, it actually doesn't mean make an object of that class. It's saying, hey, implement this interface. So what's being said is that the anonymous class implements the number carrier interface and is defined between the main braces. Now, the anonymous class demo will show us a simple demonstration with two anonymous class definitions. All right, so let me just jump over to Eclipse quick here. All right, and here, of course, is that number carrier interface. We have a set number and a get number. And here's the demo. All right, so we have two different objects here. My first number carrier object is right here. You see I have number carrier and object is new number carrier. I have a private int number. I'm setting the number. All right, here's my parameter right here, int value. Then we say number is equal to value. Then get number simply just returns number. Same thing down here. We have number carrier, another object is new number carrier. Private int number, public void set number. You'll notice with this one, it doubles the value before setting it to number. And this one just returns number. All right, because it's just set and get methods. That's all they are. Pretty simple. And you'll notice, of course, here is a semicolon to indicate these are the end of the anonymous objects. Then, of course, we just run some demo code to set the values and call the methods. So I have unObject.set value, set number, and I'm passing in 42. Then another object dot set number 42. All right, so they're both being initialized to 42. Then I'm calling the show number, and you'll notice that is passing an object and another object. Show number, of course, if you look at that, is none or up here because I actually have another method right here that simply is passing in a number carrier object, and then it just calls the get number method. So if we run this program, you'll see that it outputs 42 and 84 and end of program, because the first show number right here is an object, and so it's passing in 42. If you remember, the number, when that is passed in, just comes back out as the same value. But when I do another object, remember, it doubles it, and so that's why I have 84. Then, of course, we just have our print line statement and a program. So a pretty simple implementation of anonymous class, just to kind of give you an example. All right, now, we've talked about inner classes in depth in this chapter. Why might you want to use an inner class at all? Why don't I just create another class? It's a very good question to ask. I could just create another class object, not have to worry about inner classes at all. All right, well, in most situations, you actually don't need inner classes. There are some situations though when interclasses are a good solution. But for most things, you can just create classes like normal. Now, for example, suppose that you want to have a class that would have 2 base classes. If you remember, Java says, no, it's not allowed. However, you can have an outer class that's derived from a base class with an inner class derived from the other base class. So just think about that. Right? Your outer class is derived from one base class, and the inner class is derived from another base class. Now, because the inner and outer classes have access to each other's instance variables and methods, this can often serve as if it was a class with 2 base classes. So it's a little bit of a workaround to kind of access the ability to use 2 base classes. As another example, if you only need one object of a class and the class definition is very short, many programmers like to use an anonymous class because we don't need it to be super complicated. We just need to do this one thing. Well, anonymous class will work just fine. Now, when we study linked lists in Programming 3, if you decide to take Programming 3, you're going to see some more cases where using an inner class as a helping class makes the linked list class self-contained in a very natural way. Inner classes lend themselves very nicely in these examples. We also use inner classes when we start looking at defining graphical user interfaces or GUIs. Java has gone through several different iterations of things, like they had the swing interface, for example, and now they're moving to the JavaFX as part of their GUI interface package. But until we have to learn about what linked lists and GUIs are, these aren't really meant to be compelling examples for you. So if you're just stopping right here at Programming 2 and you never get into any more of this other stuff, you may never have to worry about GUI interfaces. You may not have to worry about linked lists and stuff like that, because for your scope of things, it may not be applicable. Can you do everything in 2 simple classes or 3 classes? I don't have to worry about inner classes and knowing how those are affecting my code. But that's going to be the end for today, folks. In fact, that's the last lesson that we have in this course. It's kind of sad that it's all come to an end, but hopefully some of you will stick around for Programming 3. Maybe some of you even take AP. But until then, I will see you guys next time.